Hello everyone, welcome back. So today we are going to address a slightly different problem. Here, let's see what is a problem statement. Here the problem statement is to implement a class named as randomized set. And this particular class has certain features that needs to be implemented in a time complexity of O1. Those are, if you are given a value that should be inserted in an O1 complexity. If you are given a value, if that value is present in the list, that should be deleted in O1. And you should return a random number from that particular list in a time complexity of O1. So why this question is special? Like, can't we do it normally? Let's try to see with respect to an ordinary list why this particular problem have a little bit significance. So if you have an ordinary list and you are given, for example, if you have an ordinary list and 2, 3, 1, 5 and you are given a value 1. If the value is present inside the list, we don't need to insert. If it is not present inside the list, yes, definitely we need to insert. But this is the problem. We need to check if val in list. So this checking whether it's present there or not itself is ON complexity. So we cannot solve the problem in O1. Similarly, if you want to delete a value from the list, for example, given value is 1, we need to again check if val in list. So before deleting also this checking happen, that is also ON. So both insert, remove. So checking the value whether present in the list or not itself makes the process a time complexity of ON. How can we evade that? How can we make it to O1? We can do it by using concept of hashing. For example, if we created a dictionary, that dictionary stores a value and index corresponding to that value. This is connected to the list. For example, if the list has 3, 2, 1 and the dictionary would be the value is 3, index is 0, and the value is 2 and the index is 1, and the value is 1 and the index is 2. Like that we can store and make utilization of this particular dictionary to recall something like this in an O1 time complexity. That's what we need to do in this particular problem. This is how we are going to implement the features here. So let's try to implement each and every functions inside this problem. Okay, let me erase this explanation part and let me make some space for each and every features. Okay, so here basically this is called constructor of a class. So here we need to define the list or the dictionary, whatever we are going to initialize. So let me initialize the list. Let me name it as ARR, and I need the dictionary or the hashing. So I'm going to name it as map. So that's it. Now let's go back to explaining the insert method. So how can we do that? We need to check. We are going to check whether it is present in the array or not. We are going to see for, let me comment it out here how we are going to store. So value index, this fashion we are going to store. So let's use that. If value in self.map, in that case, if it is present there, we don't need to insert. So in that case, we just need to return false. If it's not present there, we need to insert in a complexity of O1. How can we do that? So it is very simple. First, let me do it in that dictionary. So self.map of value, I'm going to assign it as length of self.arr, and I'm going to append this value at the end of that list also. So like that, I'm going to preserve this particular feature, and by preserving this checking will be smoothly done. Then self.arr.append value, that's it. Then return true. Once this operation is done, return true. That's how we are going to implement this feature. Then next one, how we are going to implement the remove feature. So again, we need to check whether we will be only able to remove it when it is present. If it's not present, it's a false. So if val not in self.map, in that case you need to return false. But if it is present, then we need to remove it. How we are going to do that? First, I need to get that index of that particular value that's stored in that list. For that, I am going to create a variable to access that index of self.map of value. Then what I am going to do is here, if this is the list and suppose this is the value which I want to delete, if this is the last element, what I am going to do is that I am going to copy this particular element to this index, and I am also going to update the map dictionary corresponding to this change. Then I am going to pop this particular end element there. Like that, it would be done in ON. But it was an ordinary list. If we would have randomly removed from the middle, then there was a reassigning of index would have been happening. So that would have taken to ON time complexity. Here we don't have to do that. For now, with that logic, I am going to take the last element. Last is equal to self dot arr -1. This will take the last elements. Then I am going to assign self dot map of last element in that dictionary with this particular index, and self dot arr of index with the last thing, and I just need to remove it. Removing would be like last element removing would be self.arr.pop, and also I need to delete it from the dictionary. Delete self dot map of that particular value. So this will clean it up. So this will be done in O1 complexity. So I hope you understand what are the manipulation has been done here, and at the end we just need to return after the operation is completed. We need to return true. Return true. And here there is an inbuilt function, return random dot choice self dot arr. That's it. So with that, this operation is done in O1, this is done in O1, and random is also done in O1. So as the problem indicated, we have implemented the three features in O1 time complexity. So that's it. Thank you.